Great. While we warm up, I wanted to welcome you to this session on bioinformatics, particularly on research environments. I'm here today with Thorben Seeger from Lifebit, as well as Chiara and Pablo, who will be talking more about Lifebit's product, CloudOS. And we also have Francis, who is a product manager for CloudOS. I want to remind you a few things before we start. The first one is we're using the Q&A functionality. If you go down the bottom, we've all been doing this for the last year and a half, but if you go to the bottom, it says Q&A. Please use that and we will answer your questions. We'll have lots of time for questions today. If you put your questions in the chat, we will strive to put it into the Q&A, but we might fail at doing that, so please do the Q&A. And also, we will not be using the raise hand functionality. Good. So let me then welcome you all. It's great to see so many people today, and I hope you're doing well. We are about to start now. Let me introduce first Thorben Seeger. He's the Chief Business Development Officer for Lifebit, and he will tell us a little bit about Lifebit. Thank you very much, Thorben.
Thank you so much, Augusto. And I'll just share my screen here. If you could just confirm that you see it, but I believe you can. So much of today's sessions are obviously about the incredible data that is within Genomics England, and the UK truly is a very special place for genomic data. I could argue it's the undisputed leader in genomics in the world. Ever since the discovery of the double helix to much of the technology of sequencing, all the way to moonshot projects like Genomics England with the 100,000 core. It is a place that has pioneered time and time again. And I think some of the discussion that we had today, that we had also during lunch, is about kind of this next realm of pioneering, and that is that of connected data. Of course, we do that because especially Genomics England has shown the efficacy and the power of this data. So through the clinical studies and the clinical research powered by this data, 5 times the rare disease patients get an accurate diagnosis thanks to the genomic data of Genomics England. And in the field, we know that drugs that are based on genetic evidence are twice as likely to receive regulatory approval. And of course, while being presented in, I believe, the other track right now, and very topical for COVID, the data that Genomics England holds and that Lifebit helps make securely available for research has already identified 5 biomarkers that make people more or less likely to have a bad cause of COVID, and therefore identify new ways for treatments, for better vaccines, and for care management. So you see, the efficacy is proven time and time again. So it's very clear that data can save lives, and therefore all of the data that it can save lives should be used. And we should use more and more data. In some cases, we even know that when you 10 times the data set, you can find 100 times the genomic associations. Now, there's, of course, difficulty. And there's one, that this data doesn't work in silos. So genomic data by itself is great, but it really only unfolds its full benefit when it is paired with clinical data. But also, Genomics England is only one example of a great core. There are other cores in this country, and there are other cores around the world. And of course, we should all strive to make these connected and work together. However, there is at the same time difficulty. This data is the most sensitive we know, right? So people would rather have their credit card details flying around than full DNA clinical data about them. So to upkeep that public trust, that data connectivity needs to be done in a secure way that keeps data secure and therefore retains the trust of the public. And there's exactly challenges like this and experience around genomic data and clinical data, and with institutions like the NHS, that makes the UK the ideal country to solve this, because it is embedded still in the European culture and regulation of data protection and privacy protection. And it means that the solutions that are found here, including trusted research environments, now being an export product of the UK, really means that the UK and its institutions, still at the very helm, can drive a new era of connected data around the world. And that is between national cohorts that we see around the world, but it is also in its collaboration but the many incredible industry partners and drug discovery companies that have, of course, the means and the facilities to take this wonderful data in a secure way, analyze it where it is, and develop novel drugs out of that. And that truly brings in this new era of connected data. And it's great to see so many contributions done by GEL and many other speakers on this today. Thank you.
Great, thank you so much for that, great. So with that introduction, I want to take us to the next session, where we will tell you about what we've been up to in the research environment, trusted research environments space, working together between Genomics England, Amazon Web Services, and Lifebit. I'll share some slides. Great. So perfect. So today is very much about telling you how we have been utilizing the cloud to enable researchers to discover things faster. I'll start by just a very quick why the cloud. I think it's become quite common for all of us to take the cloud as the thing where you do things, and it's indeed in the UK, the government, and particularly the Department of Health and Social Care, have now a cloud-first policy. And what we want to do that in the research space is precisely to drive these various aspects. So the first one is that once you're in the cloud, you're connected to the internet. And so it's a lot easier to bring code that exists in cloud-based repositories, bring data that exists in the things like S3 and other types of internet available storage. You can port containers and workflows. Of course, the cloud comes around because it's elastic, and so you could decide to scale your compute very quickly rather than have to wait in time to complete your projects. And the other thing you can do is you have access to many types of different cloud services. And therefore, if you need a Spark cluster to run Hill or your framework of choice, or if you want to submit many samples through, say, batch to be run on the cloud, or if you, for example, suddenly need a database to add to your tooling, then that's stuff that we have done and that you can do in the cloud very easily. In the traditional HPC model, that would be quite an undertaking from all the way from the hardware. With our partners Lifebit, we have managed to create environments where your data for your organization or your research group can be ring-fenced on their different AWS accounts, which means that it's private. You can mount your own data, you can share amongst yourselves, but protecting it from others. Is, of course, as we have come to expect from the cloud, highly available, highly reliable. And finally, as we are all now connected to the internet and starting to use lots of emerging standards, such as those from GA4GH, we can then get closer to the dreams of interoperability and federation, which hopefully we can get to talk during the question time. So let me introduce the next speaker, Francis. Francis, do you want to say a little bit about yourself?
Sure. Thank you, Augusto. Yes, so my name is Francis Carpenter. I'm a senior product manager at Genomics England, and I particularly focus on looking after our cloud research environments, or Cloud RE, as we call it, which, as we've heard already, is being developed by Genomics England in partnership with Lifebit. So, as Augusto's already talked us through the kind of benefits of the cloud that we're trying to capture, I wanted to start with a bit of an update on what it looks like at the moment. So the cloud research environment is live, and it's supporting active research for a whole range of different research projects using Genomics England data. And I wanted to just kind of give an overview of the functionality that is present and what is available right now. And then I'll go on to talk a little bit about what's happening in future and how it continues to evolve. So this slide lays out a kind of schematic representation of the current state of play. So the dark green box around the outside shows the way that users access the environment. So users log in through a virtual desktop, a VDI, which we use from Amazon Workspaces. So this gives users access to a virtual machine in the cloud through which they can then securely access data and analyze it in CloudOS, which is the application that Lifebit developed. And so those the green boxes then inside in the lighter shades are representative of specific CloudOS workspaces. So the way CloudOS is organized is that users do research as groups in private workspaces. So each workspace represents a group of researchers, for example, a specific pharmaceutical or biotech company, or a specific group of academics working on a common theme. And as Augusto was saying, based in the cloud, it gives us a lot of flexibility to organize this so that these workspaces are secure and privately organized. So you can easily collaborate and share data, analyses, results with each other within a workspace, but you're very private and secure from other workspaces. Once you're inside a workspace, there's 5 kind of main core elements of functionality within the CloudOS platform. And those are in the sort of white dotted lines below. And I'll just talk you through those at a sort of high level first. So the first is around the data that we make available from Genomics England, but also the capacity to bring in data that you might have from other research and to analyze it alongside Genomics England data. The second is the cohort browser, which is a graphical interface for analyzing our participants' data, both in terms of phenotype and genotype. The third then is workspace management, which is effectively all of the ability to manage, for example, how much is spent on resources in the cloud. The fourth is around doing interactive analysis in the cloud through Jupyter notebooks. And the fifth is then for non-interactive analysis for large-scale compute. And together these give a sort of full set of tools that can be used for end-to-end analysis, from getting access to Genomics England's data for an improved project, exploring it through to performing large jobs, and then exporting the data out at the end. So I'll just talk a little bit more about the current functionality available on each of these. So in terms of data import and availability first, so we maintain the data in Amazon S3 buckets, which are sort of cloud storage units, and we can provide access to all of GEL's data through that. We also provide access to common public data, things like 1,000 genomes, nomads, GTEx, etc., for you to analyze alongside. And as I mentioned, there's also capacity to bring in data from external sources. So any data that lives in the cloud in either a public or private S3 bucket, you can, as a user, import it yourself to analyze alongside GEL data without having to ask for our support or to raise a ticket and to wait for us to do it for you. The storage that you have then is private to that workspace, so you can import and store output privately without it being shared with any external colleagues. And there's also access increasingly to additional types of file storage like Lustre FSX, which is a high performance parallel file system provided by Amazon, which allows you to access and mount data much faster than from S3. So once you've got access and you've brought in any data you need, you can explore Genomics England's data through the cohort browser. So it's a graphical interface, as I say, where you can define Boolean queries, for example, looking for participants with a mix of phenotypic and genotypic characteristics. So women who have been diagnosed with a certain kind of cancer before a certain age with a specific variant. And you can then export that data for further analysis. You can also define multiple cohorts and compare them to each other, and increasingly also programmatically query it. So it's a growing tool for easily kind of exploring Genomics England's data. Once you've then browsed a cohort and you've found some participants that you're particularly interested in, you may then want to kind of do some further exploration interactively. So in the bottom left then is the interactive notebook analysis. So in the cloud, when you want to do analyses, you can spin up compute on demand, as we mentioned, and you can then run Jupyter notebooks on these, where you can have access to common kernels like R or Python, either on single computers or on clusters of computers, for example, Spark clusters, to perform an interactive analyses on. So very similar to working in, for example, RStudio on your own local machine. And what you can do then is install all the packages you need, either from trusted sources like CRAN or PyPy or Bioconductor, or as containers from sources like Docker. And you can also clone in your code from, for example, GitHub as well. So you can bring all of the code, tools, software you need in together with gel data to analyze interactively. Beyond that, in the bottom right-hand corner is the summary of the capacity for non-interactive pipeline jobs. And what we mean here is large-scale batch analyses. So the interactive analyses are great, but they're often constrained by the computation of the computer that you're running them on in the cloud, just like running them on your local machine. So when you want to do very compute-intensive jobs, you might want to run them as a non-interactive job, which can then recruit and scale up very large numbers of machines in parallel to perform analyses very performantly. And for these, we have support for running analyses with a number of common workflow languages that are used across the majority of genomics workflows, like Nextflow or Cromwell WDL jobs. So you can import those workflows from GitHub and run those pipelines. And you can also then either through those workflows or independently run containerized jobs from places like Docker Hub or Key.io or Amazon ECR as well. As Augusto mentioned, the benefit of using a platform like CloudOS to do this is that a huge amount of the complexity of running these analyses on the cloud is managed automatically for you. So for example, CloudOS uses AWS Batch to auto-scale the jobs. So for example, you can then recruit more and more computers to complete the analysis based on the kinds of constraints you have around cost or price or things like that. So those sort of four elements cover the end-to-end analysis. And then the last main element of functionality that I mentioned in the top right is the workspace management. So this is just where, as an individual or as a team, you can set limits to working in the cloud, for example, through permissions for what data colleagues can access, or to set spend budgets around. For example, I want to make sure I don't spend more than $1,000, on big analyses. So that can be sent, and you can also link accounts here as well. So sorry for the long spiel. I hope that it's trying to give a summary in a short number of minutes of what's a lot of complex tooling. But what I'm trying to sort of summarize with is that what we're trying to develop here is all of the tooling required for sort of end-to-end analyses, from starting to first landing in the Genomics England environment through to running big complex pipelines or building tools. So I'll pause there. Catch my breath. Cool. Then just quickly then on the second slide, I just want to really emphasize that what I just summarized is really the current state of the cloud research environment. So we've been working on it together with Lifebit for the last number of months, but it's still evolving, and it's evolving at rapid speed, both based on the requirements that we bring as Genomics England, but also that our customers and our users bring. So what I'm really excited about is getting more input and feedback from users, so that we can make sure that we shape it to what requirements you have. And so it's really a call to arms that if you're interested in working with Genomics England data, but the research environment doesn't do something you need, then we can partner and work together to make it possible. And on this page, I just summarize in a few incredibly high-level buckets, an incredibly non-exhaustive summary of some of the example things that we're working on at the moment to continue building this out. So for example, in the top row, there's a number of pieces that we're working on across Genomics England to help bring the cloud research environment together with other elements of tooling we make available for research. So for example, our research environment 1, that was our on-premise research environment for originally developed for the 100,000 Genomes project, we're looking to merge all of that functionality together with CloudOS and CloudRE into a single hybrid environment so that users have the option to work either on-prem or on the cloud as they prefer, and also to connect it to our on-premise storage so that, again, users can very flexibly work either with cloud storage or on-premise storage, move results and data around between them and work however they prefer. Of course, in the second row, we also continue to make lots of improvements to CloudOS, as Lifebit did in parallel. So again, just a few illustrative examples that we're currently working on and will be releasing in the near future. In the top row, some work around making it much easier to set up analyses to run on gel data. So we make a huge number of VCFs, BAMs, etc., available across the 100,000 plus participants that we have genomic data on. And there's lots of work being done to make it easier for users to search these files through metadata, things like plate key, participant ID, so they can more easily find the data they need and feed it into their analyses. We're also doing work on better supporting data-heavy analyses. So, of course, a lot of the work in the cloud is best suited to the cloud because it's very compute-intensive, and that means requiring a lot of data. And so what we're working on is using, for example, Lustre file system, as I mentioned before, to support all of our kinds of analyses, and so that all of those analyses will be much quicker, much cheaper for users to run. And we're also improving a lot the work on data exploration through the cohort browser. So, for example, to increase the number of sort of analytical journeys that are supported in terms of moving from the question about a cohort of interest defined by phenotypic characteristics to then explore all of the relevant variants they have, and vice versa in the other direction. So I'm interested in a sort of variance. What can I learn about the phenotypes as well? So much happening on that direction. And then lastly, I think this is preceding some of the probably most interesting questions in the whole space of TREs. Is a lot of work that we're really accelerating around TRE federation. So also feeding back to the points Thorben mentioned about very international data and the importance of collaboration across genomics efforts and research environments. Genomics England and Lifebit are very focused on federation and adopting standards that will make it easier to analyze across environments. So, for example, adopting standards like the Global Alliance for Genomic Health Standards, DRS and WES, Data Repository Service, Workflow Execution Service, for example, to make it much easier for users who are working in other environments to come to Genomics England environment and for it to be interoperable, for them to be able to run their analyses in the same way. And then lastly, for example, adopting standards like Beacon that make it easier to discover our data. So you don't have to have access, but you can find out, for example, how many participants do Genomics England have with this variant and this phenotypic condition, for example. So huge amount of work ongoing, lots of exciting development that hopefully makes it easier for researchers to come and explore gel data and do their research on it. This is, again, not exhaustive at all, but we really would love to have input and more feedback on what would really make the difference and make it much easier to do your analysis with our data. That's me.
Great, thank you so much for that, Francis. Next, we have Chiara. Chiara has been our partner in crime from the Lifebit side, and essentially we work together as a team. So Chiara, why don't you introduce yourself first, please, and then tell us a little bit more about where you guys are going.
Yeah. Hi, everyone. So my name is Chiara Bacchelli. I'm the Precision Medicine and Human Genetic Lead at Lifebit. I'm also the Client Success Manager, working very closely, always from the beginning, with Genomics England, to just make sure that the customers and the users of Genomics England and the CloudOS environment are actually successful. What we have planned, so we realized quite earlier on, actually, that not all the users that are embarking in and trying to use the platform and the CloudRE, as we call it, are expert in the cloud. And with that comes some difficulties. Not all, but some clients have never worked in the cloud, for example. So what we worked very hard to put together is a as we call it, user success plan, just to make sure that absolutely everyone, despite the fact that you have been previously working on the cloud or not, are actually be able to succeed in what your goals are, performing the research and the outcome that you want to achieve with Genomics England data. So our plan is very comprehensive, is in 3 stages. So we have a training, which is absolutely comprehensive, end-to-end user journey, following the path, actually the journey that Francis illustrated, with videos, step-by-step exercises that the user can do with us, but also at their own pace, to really get familiarized with working in the cloud and with the Cloud RE platform as well. So we then give more training. So there are lots of documentations online. There's onboarding session that we organize together with Genomics England, both on where to find the data, pipelines, how to find them, how to import them, etc. And in this onboarding session, you will get to know the Lifebit trainers, and as well as the GEL bioinformatician that can also help us. After those 2, let's say, steps, there's the support is ongoing as much as you like, basically. So what we call one-to-one hypercare support is the support that we give to every user that comes into the platform, and those are in the form of one-to-one working sessions that can last half an hour. What we normally typically see is that any user probably needs 2 or 3 of those sessions. Sometimes more, but average of 3, with one of our bioinformaticians to really work. And this is our hands-on session. So let's say that you have a pipeline, you want to containerize the pipeline, or you have a pipeline and you're running it, but you get stuck somehow. So we will help to debug. We help you with the building your pipeline, how to run Nextflow, Dockerize containers, everything. So it's the all support that we give. So our aim ultimately is to make sure that everybody is successful. Everybody is successful in using the Genomics England data in the Lifebit platform, let's say, and achieve their goals and the results and the research results. So, and that support, I'm saying 3 sessions, but it can be as long as anybody needs and so yeah, I think that's me, all I wanted to say.
That's great. Thank you so much, Chiara. Just for those that don't know, we in GEL have a team, and we are having all of our bioinformatics team going through the same process just to make sure that it's impeccable. And I only hear good things about it. So thank you so much.
Okay, thank you.
Great. So that takes us through our presentation, and we have 25 minutes of questions. Before I do that, let me introduce Pablo. Pablo would you mind introducing yourself?
Yes, thank you, Augusto. Hi everyone. I'm Pablo. I'm Dr. Pablo Prieto. I'm CTO and co-founder of Lifebit, and I oversee mostly the product development. We mostly obviously interested and invested into provide the best solution to Genomics England and its research community.
Perfect. And Pablo, just to warm us up a little bit, I would love if you can tell us about federation. And by that, I mean, we all talk about federation. Federation seems to be the dream. And so I think it's 2 questions. First of all, how do you think about federation as a problem? What are the different aspects of it? And then secondly, what is available now between the Cloud RE that Lifebit provides Cloud OS for, and then all the functionality that Lifebit can help? Sorry, quite a long question, but so let's start with how do you think about federation, and then what can be done right now?
Yes. So federation, as you mentioned, Augusto, it can be quite complex, and it can also come in different flavors and different solutions to tackle different problems and use cases. We typically like to differentiate federation on different levels or different modes, let's say. we've got what we typically call, well, obviously there is the no federation level, right? Which means that there is absolutely zero basically automation in terms of federation, and any analysis that has to be done, it's run manually. And if you need to do any other type of analysis, it means that you will go to a totally different environment outside, for example, Genomics England, and you will have to redo absolutely everything from scratch, right? And that touches different things. It's not just about compute or storage or accessing to the resources in the cloud, but it might mean about how do you actually bring the same tools, the same code, the same applications. How are you able to actually even replicate with the same parameters and configuration, even if you have the same applications, right? And yeah, then on a more or less automated manner. So that's not available at all on the no federation model. Now, when you start to speak about federation, we've got what we typically call partial federation. Now, partial federation, there are different levels or flavors. We can be speaking about partial federation from the storage perspective, where you might have the capability, which is something that we currently have the capability in Genomics England platform, Cloud OS. You have the capability, given a set of compute resources and machines in cloud, in Cloud OS, in Java, you might have the capability to actually access, to link and connect to different data sets, even the external data sets, and have this combined with, for example, Genomics England data, right? So there is here a partial level of federation in terms of accessing data. Now, there is also another model where you might be able to actually federate in terms of compute, where you might be able to basically ship and offload certain queries and certain compute to distributed locations, right? Now, that is the holy grail in federation, and what we call the full federation model, is where you combine basically everything all together. So the storage federation capabilities together with the computational resources. Now, that brings additional benefits, because you are not just being able to actually just find any analysis on its own location without having to move around or to seek for computer storage resources separately, but you can also bring federated queries. You can basically bring forward entire federated joint analysis, which allows you to, regardless of where is the data, each location will have capabilities to actually compute on demand and basically provide the results. Now, that also has some additional options, because depending on the type of use case that you are performing, if you just want to be able to replicate automatically analysis in a federated manner across different locations, you can just do that even in parallel. You also have the capability, once you achieve full federation, of even running federated and aggregated applications, which will allow, for example, this is a typical use case on machine learning applications, to actually offload the certain compute where the data is, take some of the learnings to a central kind of component, which will basically take care of redistributing and update data and update, for example, machine learning model into the different new sites, right? And basically keep proceeding until the entire pipeline has been finalized.
Perfect. Thanks so much. Anyone else would like to?
Yeah, I was just gonna add something in. So I think it's really interesting to hear from Pablo on exactly what the federated analysis looks like. I think from Genomics England perspective, what we're really trying to solve for, especially with a big interest in rare diseases, is overcoming fragmented data. And I think that for federation, that means not just being able to run queries on different data sets, but also to discover fragmented data and to get access to fragmented data. So I think federation, as Pablo says, is a very extremely nebulous concept. But really, I think what we're also trying to explore within the same sort of thinking or work is, how do we also interact with other genomics data owners, custodians, to make Genomics England's data more easily to discover, particularly for rare diseases, through single interfaces or searches, and then also make it more easy to get access to. And then once you're in the environment, to be able to analyze the data in the same way that you're doing it elsewhere, as Pablo was saying, or to analyze data both with Genomics England's data and with data in other environments. So I think that whole chain of journey from first discovering the data or being able to discover the data through to analyzing it is all kind of part of federation.
Cool. And perhaps a follow-up on that. You spoke a little bit about GA4GH standards, and Genomics England is part of is a driver project for GA4GH. And there are many standards there. I was wondering, particularly on the cloud infrastructure, what sort of standards are we looking to implement and why those first? Perhaps, why don't we start with Francis?
Sure. So I think that, as you say, there's a huge number of standards and things being developed by GA4GH, which is very exciting. And I think that the degree to which we adopt them and which ones we prioritize and focus on first, we're hoping will be very driven by collaborating with partners to unblock real use cases and to support real projects. So there's definitely standards that we think are maybe more feasible to or easier to implement, and ones that we have a view on how what would be more impactful. But we also don't want to just kind of adopt standards for the sake of it, or to implement things that seem like they make sense from us. What we really want to do is work with colleagues in academia, in industry, so that someone can come with a question and say, this project on this rare disease is only possible if we join, data from all of us, or Our Future Health, or UK Biobank, FinGen with Genomics England data, and for us to work together to say what would really unblock that analysis. So, we're really looking to drive it through that kind of user-backed prioritization. In terms of specifics of working on the cloud, I think the sort of the holy grail of having the whole user journey integrated and federated, I think is still a way off. It's a real utopia. So I think the things that I personally would look at prioritizing the most are firstly around the data discovery. So the standards that let others discover Genomics England data and what's available, and decide whether or not it's worth following up on. And then once they've got access, because that's very complicated and rightly has lots of governance controls in place, the standards that let them do their analyses more easily or in a way that they're more used to doing elsewhere. So things like the data repository service that would let them interact with and explore Genomics England's data, in a similar way that they could do, for example, on the Terra.bio platform that's used by the Broad Institute.
Great. Cool. I have a question for everyone. Would love to hear your views. So a lot of us in the bioinformatics space come from an institution that had a large high performance computing platform, and we would normally use Bash. Perhaps would have the code close to the data in some scripts, and that feels very comfortable for a lot of us. Perhaps a Linux desktop if you want to soup it up all nicely. And so it's more like, what is your sales pitch as to why should one move to the cloud? I know we've talked a lot about this, but if you had to just say, Augusto, you really have to try to move to the cloud, what would be the things you have to that I should focus on as the key benefits? And because I love two-part questions, what are the kind of the main challenges that I as a user need to be aware of? So why should I move, and what are my challenges? Anyone that wants to jump in?
Well, I can jump in though, from the technical side. I think Pablo needs to answer a little bit about the unrivaled scalability that's possible there. So I'll let Pablo answer that as co-creator of Nextflow. So he knows how to really leverage cloud. One thing that me and my team from the commercial side on the kind of the pitfalls of the cloud, as well as the fears that exist around it, help institutions around the world with, is than of cost, right? And so Genomics England, for example, is the government, right? It's owned by the Department of Health. It's funded by the taxpayer. And it's not really fathomable to think that when pharma companies come into this environment and run large analysis that costs a lot of cloud costs, right? That the taxpayer should be paying for that. And for that, there are strategies, there are technologies. We're using it as part of CloudOS to measure that, to recuperate these costs, and generally put institutions like this on a more sustainable path. We deal a lot with large universities where obviously kind of the HPC is it's the God-given infrastructure, and it's just there. It doesn't cost anything, and people don't associate any costs with that. Yet we see more and more universities actually charging their research groups and their PIs actually for the use of HPC, and then it all of a sudden isn't so cheap anymore, and it's not really sustainable. So a lot of the conceptions around the cloud that, oh, now I need to pay for something that I don't have to in my university, that is falling by the wayside, especially when you combine it with like sustainable models that source the funding for computation either from industry or for the different groups. And the most important thing, though, in terms of the upside, and that I handed to Pablo, is of course the elasticity. You have the most powerful computation on Earth basically at your fingertips. Something that an HPC system can never do. So Pablo, maybe you can expand a little bit on that.
Yes, absolutely. Thank you, Thorben. So on touching on the elasticity topic, I would say it's not just on the elasticity, but also on the flexibility and capabilities of different amount of level of resources that we actually have in the cloud. It's when we speak about compute resources, right? We can tap into a wide variety of different compute resources. These can be even specialized for specialized tasks like GPUs or FPGA instances, for example, to run typically accelerated applications like machine learning, or for other primary and secondary genomics pipelines that manage to basically make use of those accelerated resources and deliver results with a really low turnaround times, right? So that there is that capability, plus the cloud also, I think, brings the benefit of providing many different services for anyone to actually build upon, right? So I think something that Francis was highlighting to the extensive capabilities and the amount of improvements that keep basically coming and will keep coming into the cloud research environment is based on the capability of having almost any type of service available that you can build on top of the cloud and provide new and additional solutions and enhancements and further new capabilities that, especially nowadays with larger volumes of data, with new different data types that are coming into such research environments, is going to be requiring to not have a static environment, but rather have a very dynamic environment and applications that can progress and evolve as the needs evolve across time. So I think that's one of the critical capabilities that the cloud-specific environments can provide.
Cool, thanks for that. Yeah, I think as I tend to think about this problem, in the past we had a single type of compute, and therefore we focused on software that could use that compute, and that constrained us a lot. Now we can think of the whole types of computer architecture, software, and data to some extent together as we start to, for example, deploy more deep learning models. All of those things have to come together quite seamlessly.
Yeah, there's also, if I can add one more thing about the democratization, right? So what we're doing with this data is, we want to democratize it so that it's being used more, but it also means countries that, haven't had a benefit of major government funding for the last 10 years to set up a huge HPC structure. We see that, for example, in Hong Kong. So Lifebit runs the precision medicine program for Hong Kong, and there was a greenfield. Nothing was existent there, but what is existent there is an AWS data center. So very quickly we can turn around in the span of just a few months, span up a very, very sizable national precision medicine program, because you can on demand use that infrastructure, and that democratizes access to way more countries and organizations around the world.
Right. I was hoping we can then switch a little bit to talking about users and types of users. So we have a lot of different type of people using the data, and we have everything from clinicians that are interested in trying to solve a case and try to be able to diagnose them, all the way to someone that has developed complicated machine learning models. They're used to the tooling that is available in the cloud. Perhaps they're even cloud native, as in they consume cloud services directly. So I was hoping either Chiara or Francis, you can tell us about how we try to cater for those different types of users and which users are like the prime target right now to just jump in and start doing this.
Yeah, sure. I'm happy to go first as Francisco. I'd like to be less English, that's always nice.
Francisco is our ML expert in the team, so I confuse them.
Not easy to mix up with me, but yeah. So I won't try and recapitulate a lot of the thinking that we do on users and segmenting them and trying to put them into boxes because it's not trivial. But I think there's some very high level summaries that are maybe worth putting out there. So as you say, there are certainly many users at the kind of, I guess, cutting edge of sophistication in terms of working in the cloud, for whom many of the things that we discussed that are already available in CloudOS will make their research much closer to what they're used to doing outside of Genomics England's research environments. It'll be much more comparable, much more similar to what they're used to. So, for example, to work with code repositories like Git, to work with containers, big workflow languages like Nextflow or WDL. Many users we have particularly from commercial industries are very used to working on similar kinds of platforms, similar kinds of setups that they might have within their company, for example. So those users, the cloud is very intuitive to them, and they're very used to working on it. I would say at the other end of the spectrum, in terms of maybe technical proficiency, you have users who are more used to, or who really are, for example, clinicians who don't have any real experience or history of coding. They're not sort of trained bioinformaticians, and for them, many of the things that we've spoken about are very scary and intimidating, and they don't have an idea what a container is or what Docker is or how it differs from GitHub. And for them, some of the aspects of the cloud are intimidating. There's a lot of learning curve. But there's also a lot of potential in the cloud for building tools that make those kinds of users much more comfortable. So we spoke about a lot of point and click things, more intuitive graphical interfaces. And I think the real aim of Cloud OS is that it, and what we appreciate it from Genomics England side is that it's trying to support both of those extremes. From users who want to have a lot of agency and control about how they work and are really expert in cloud, down to users who who are clinicians and just want to explore a single participant or a set of participants in a very intuitive graphical way. And of course, I obscure a huge amount of complexity in the middle. We have certainly many users in Genomics England, like bioinformaticians, used to working on-prem with HPCs. And for them, some aspects of the cloud are very non-intuitive, and there's a certain amount of a learning curve. And so a lot of what we're focused on, you probably get from the slides we presented, is both how do we develop the platform to be more intuitive for those kinds of users, but also how do we help them make the transition, for example, through the training Chiara mentioned, the videos and the guides, and collaborating with others like the other data custodians or other genomics bodies like EBI, who are trying to solve these same kinds of problems. Because I think the whole industry is moving towards the cloud, and so learning and from a user perspective, but also helping upskill people is also part of what we believe is very important for Genomics England to do.
Great, thank you. Chiara, do you want to comment on that? Perhaps expand on the training. I'm curious how people feel about whether the training did really get them going, or is it just something?
Yeah. So what I I'm seeing by really interacting with the user when we do the training is that there's for everyone, and this is spanning to all different skill set. They're very keen to learn, especially the one in between that Francis mentioned, right? Maybe used to working on-prem and they just not sure about the cloud, but everyone that I interact or we interact with, they're really keen to learn. And I think the tools that we give them and the support, constant, continuous support, both sides, Gel and Lifebit, is very appreciated. And I think they find it useful, and they, you know, as I said, we will not let them go until they are successful and achieving, well, you know, but what I see is that a lot of people are very keen to learn, to work on the cloud, and a lot of academics now as well, you know, so I enjoy that. And for the other point about the other side of the spectrum, people like clinicians or clinical scientists like I was or am, is that we really strive in Lifebit and with the help of Gel always to improve on the UI and to make things extremely, you know, simple for somebody like me. So we have the core browsers, Francis mentioned, and other tools that are really, you know, for exploration of the data and user-friendly. The UI is nice and easy to use. So we are really trying to cater for the, you know, end of spectrum and anything in between, always with the UI as well. So yeah.
Perfect. Perhaps for the last question, I wanted to ask the panel, maybe either Pablo or Francis, whether you can tell me how a user can solve the following problem. I work for a company. My company has a whole bunch of genomes stored in, let's hope, an S3 bucket, private S3 bucket. And then I want to analyze that together with the data in Genomics England. I have some custom software that I want to use. Let's say I have a special association scan approach algorithm. Can I do that, and what sort of steps do I need to go through to do that? I don't know if Pablo or Francis want to go.
Sure, I'll go first. I see Pablo looking at me. So, so the short answer is yes. Luckily, you asked, Augusto, you definitely can do all those things. You asked the right question. So I mean, assuming you have access to Genomics England, England's data in the research environments, you can bring data into the environment securely just for your workspace. So, for example, if it's in a private S3 bucket owned by your company, and it has a whole lot of I don't know, BAMs or VCFs or whatever, what we can help you to do is set the permissions on that bucket so that all the data can be securely read from your CloudOS workspace and just by your CloudOS workspace and not by any others. So it's accessible from within the Gel environments to you and to your colleagues, but not to anyone else. So then you would have access within the environment to Gel data alongside your own data.
Is that read-only, or can you also export data that way?
So you can't export data in that way. So the whole kind of principle of the research environment that maybe we assume some knowledge of is that it's really set up in a way to be to restrict what data can be written out. So you can bring data in through a private S3 bucket, but you couldn't write anything back to it. And that's just to make sure that all of our Genomics England participant data is secure. So all of the data extraction has to go through a review process, and it can only be an aggregate level that doesn't allow re-identification. And then once you've got the data in a read-only manner, you can then bring in other tools. For example, if you have your own software containerized, you can have it in a private container that could be pulled for a workflow or run as a Docker container itself on the data and on Genomics England's data at the same time. For example, if it's in a container repository like Docker Hub or Amazon's ECR container repository. And then you have all the tools and data you need. And I think the last bit I'd add is, you kind of don't have to do it alone, as Chiara says. We're here to kind of help guide people through that process. So if anyone has questions on how to do things, either we can set up one-to-one calls, or we can provide all the information. So we're definitely here to help.
Great. So thank you so much for that. With this, we would like to thank all the panelists and all the listeners today. I hope this was an informative session, and I want to wish you a great rest of the meeting and a great rest of your day. Thank you very much.